Hello, I'm Tim. Great to see all your beautiful faces here today. I am the founding engineer at Effectful, and you can find me in a couple places on the interweb. And I'm also in the Effect Discord hanging around. And I just hack on Effect all day, pretty much. And today I'd like to talk to you about Effect Cluster, as Johannes pointed out to you, and also kind of like an underlying kind of theme to this will be Effect RPC as well. And first, I'd just like to kind of answer the question like, what the heck is Effect Cluster? Like, do I need this? What does it do? Well, the first thing I'd like to kind of answer, my first kind of response to that is it's kind of TypeScript growing up, and I think like over the past few years we've seen kind of like an evolution in the TypeScript ecosystem. If you don't know my history, I started Node.js back when it was like 0.1, and it was like hacking on it with like Ryan and the team. But I've kind of like I stepped away from it for a long time just because JavaScript was dynamic. It didn't have a type system. I wouldn't want to debug JavaScript in production. So I was kind of like in the kind of like Ruby Elixir world for a long time. And I really fell in love with Elixir because of its kind of like it's how it structures, how it kind of like models concurrency and distributed systems. So if you're not familiar with Elixir, who's used Elixir here? Yeah, and I bet everyone who's used it loves it. It's a great language, has the nice functional aspects that we know and love here as users of Effect. But one thing that really shines with Elixir and things like Akka and all these clustering solutions is the actor model. And TypeScript hasn't really had a kind of like piece in the game for this. Like only very recently we've seen TypeScript kind of take over the JavaScript ecosystem. And in the beginning, TypeScript was kind of just like sprinkled on top of your JavaScript. And people really struggled with it. But only over the past few years have we seen like TypeScript first software being built. And this is where Effect, my journey into Effect comes in. Effect is really TypeScript first framework that really makes the most of the type system to kind of like assist you in your development. Like we have errors as values. We represent dependency injection in the type system. So Effect fully leverages TypeScript to make your development easier and more production ready. So we're actually starting to enter this phase in TypeScript where we're actually getting some of the nice things that other languages have had for a long time. Like if you've been using Scala or Elixir, as I mentioned before, or dare I say it, Java, you've had these frameworks that are like enterprise-grade, production-ready, help you to create production-ready systems. And for Effect Cluster is like a step in that direction. So we're like bringing the power of these kind of like distributed system solutions to TypeScript. And they all kind of like revolve around this single writer principle, which is write should go to one place. Otherwise you introduce lots of issues like contention and the list goes on, but I won't get into that. And one other thing a cluster is aiming to do is allow you to write business logic in simple building blocks that we call entities. Just to bring back to Elixir, you have like the gen server model, which allows you to like build your business logic in these kind of like building blocks. And the other thing it allows you to do is treat multiple machines or like Kubernetes nodes as one single unit. So like drawing back to Elixir, you can have like a Beam cluster, and you don't need to really worry about where something is on the cluster. You just kind of like reference it by like like an ID that you define. So why use the Effect cluster? It just makes it a lot easier to write distributed systems. It's like if you have more than one computer, which you probably do in production, when you use Effect cluster, you don't have to worry about, you don't have to think anymore about like what node is this pod on, what is its IP address, what is its port. You just need to think about your business logic. You just think about your entities. It heavily relies on effect schema to model your domain. And because of that, we can derive a lot of things. So you don't have to think about your communication layer. So schema will make sure whatever message you're sending, it will be properly serialized. And if it just so happens that an entity was on the same machine, it will just send it locally. So whether an entity is living on a different machine or on the same one, it will just make sure your message is delivered for you. And you also don't need to think about the distribution of work. So the more entities you have, Effect Cluster is what we call a sharding framework, and it will make sure everything is evenly distributed over all of the machines in your cluster. So I'll quickly cover how does it work, and it's heavily inspired by Shardcake, which is a Scala library for Zio. So a cluster has multiple runners, and you can think of these like a single machine in your cluster. And each runner is assigned shards, and the shard is a unit of distribution in the cluster. So let's say the number of shards is fixed. So you would have 300 shards, and your number of runners might grow and expand as your cluster might auto-scale. And regardless of how many runners you have or machines you have in your cluster, the 300 shards are always evenly distributed. So if you had 300 shards and 100 runners, each runner would have 3 shards. And your entities are kind of allocated to the shards. And in the Effect cluster, right now you have one shard manager, and its only job is to assign shards to your runners. And that can operate with downtime. So if your shard manager goes down, the cluster will continue to operate, and when it goes back up, great. So over the past, cluster has had a long journey. Matthias started the work last year, and he talked about it at the previous Effect days. So shout out to Matthias. But we started to take a step back and think about a few things, like what if persistence was woven into the messaging layer? So in Shardcake, messaging is all done over the network, and if your server is down, then the message won't be sent, it won't be delivered. So what if persistence could be woven into the messaging layer? So even if one of the runners was down and you send a message, when it comes back up, it then processes it. So we want to ensure that messages are always eventually delivered in some scenarios. So we want to have the ability to turn this persistence on and off. Like maybe you want a volatile message, maybe you want a persisted one. And by doing this, we add a kind of resilience to our system. So if a pod goes down or if a client goes down, when they come back up, they can resume where they left off. And we live in a world where chaos happens. If you've been in distributed systems for a while, you've heard of the chaos monkey. Pods go down. Kubernetes likes to reschedule things sometimes. Resilience is quite important in this day and age. And the other kind of benefit of this is we get deduplication of messages. So if your client restarts and it tries to send the same message again, with persistence, we can identify that, hey, this is the same message you sent last time. So we'll just subscribe to the previous one you sent. So the other thing we wanted to do in this rewrite is improve the developer experience of writing your entities. And we wanted to improve the networking performance. And to do this, we rewrote the Effect RPC package. So it has an entirely new API with a more modular design, so you can swap parts of the framework in and out. So you could, let's say, swap HTTP for WebSockets, or if you wanted to use raw TCP sockets, you could. And you can also swap out the serialization, so you could use JSON, message pack, we might add more later. And it now powers like all of like the communication within Effect Cluster. So that's enough talking. I'm now going to get into demo mode. And to do that, I'll first show you like what the API for cluster looks like. So we go in here, Effect Days. First I'll go over the schema. So in Effect Cluster, sorry for you who don't like a light mode, but I do. So here we have, maybe I'll start with the entity API. So here we have defined an entity called a battleship. So this demo today is about distributed battleships. And I've defined like 3 procedure calls for this entity. We can shoot a battleship, we can shoot it with some delay, and we can also shoot it into the future. Maybe that should be named shoot in the future or something, but naming things is hard. And I'm also annotating this entity to say all the kind of like messages for this entity will be persisted. And you can also like override that. So here we could go annotate, cluster schema not persisted, and then we could say false. And then only these 2 will be persisted, and that one will be like a normal network volatile message. So here I've kind of like have a couple of special payloads, so we'll take a look at this one first. So here we define like we're going to define the delay for this bullet, and we're also going to implement primary key. And by implementing primary key, we kind of like opt into the deduplication of messages. So we can say here, like, for every message that's sent to this entity with this target, only ever send it once. And then we can make sure, like, if the client tries to send it again, it will then subscribe to the previous message result. And then the other payload here is we're using another kind of like interface called deliver@. And by doing that, we can say, this message will only be delivered to the entity at this kind of like point in time. So by doing that, you could say, send this message 6 months into the future, and in 6 months' time, the entity will then receive the message. So that's kind of the entity API. And then when it comes to implementing like your runner, you first need to like implement your procedures. So here we're like providing like effects for each of those procedures that we defined. So when we shoot, we're just going to log boom. And we're just going to add some annotations to the log. Shoot with delay, we'll just sleep for a period of time and then say done. And then because we're using like that deliver@, trait or interface we saw earlier, when this message is finally sent to the entity, we're just going to say, hey, we got it, it's done. And then because I wanted to celebrate the best module we have in Effect, cron, I was paid to say that by Sebastian. I've added a cron ship to the cluster, and this kind of demonstrates singletons. So we have entities, but another thing that we have in cluster is singletons, and a singleton represents a single running thing in your cluster. So no matter how many runners you have in your cluster, this will only be running in one place somewhere. And when this thing boots up, it will say the cron ship is sailing. When it shuts down, it will sink. And like every minute, it will use cron to say the cron ship is cronning. And then at the end, we like merge all of the stuff we want to run on our cluster, and we kind of like, in platform node, we have a bunch of like cluster modules for defining the layers for cluster. So here I've got, here I'm using like TCP sockets, and I'll use the SQL message storage backend, and I'll then provide my SQL client. And also in here, I've got a couple of like clients. So you can also like connect to your cluster, but without participating and running the entities. So you could have like client-only participants. So here we're like grabbing the client for a battleship and then just like firing messages at it. And then we also have one for like persisted messages and one that goes really fast. So let's see how this works. Hopefully I can talk to my cluster. Yeah, there we go. So I've got a cluster of 100 nodes on it, just for fun. So the first thing we'll do is get Postgres up. So there it is, booting up. And the kind of like one thing we need in a cluster is the shard manager. So we'll spin that up. Shard manager. And that will crash unless, oh yeah, Postgres is up. There we go. Good, we've got a shard manager. So now we're ready to deploy our runners. So all you really need for a cluster is, if you don't have to use persistent messaging, but in this case we do, so we've got Postgres. So the first thing we'll do is deploy our battleships. So those are all of our runner services. So here we go. And we're running, and there we go, the cron ship is up. Sailing and cronning, that's what we like to see. And because we've only got one pod, the singleton is on this. But if we were to like scale this up to 10, then it might move to another pod to ensure. So when you spin up more runners, then the shard manager will redistribute the shards, and then you might see like the cron ship move to another runner if the shard is reassigned. And the cluster will always make sure like a shard is only ever running in one place, so you never get like the duplication of processing or duplication of entities. So I'll scale that back down to 1. So the next thing we'll do is kind of like deploy one of the clients. I think it was the shooter. Let's wait for that to boot up. Oh, I need to scale it up. So this is, we disabled persistence for this message. So this is just an example of like normal messaging over the network. So we're shooting ships, and then if we go here, we'll see like the bullets coming in and it going boom, boom, boom. Great, our battleships are dying. And if we scale this to 0, then those messages will fail to send because, yeah, it's frozen. Because those messages are reliant on the network only. So the next thing we'll take a quick look at is persistence. So if we, I think I called it slow shooter. There we go. So we can see it sending off a bunch of persistent messages, and then like sometime later, the battleships will respond. So here we can see the messages have been received, but this time all the messages now are persisted. And just to kind of like demonstrate that, see that we've got our results back, I'm going to turn off all of our battleships. I'm just going to, well, I'll quickly demonstrate like the kind of like deduplication aspect. So if I restart that, because all the messages would have the same ID. Oh. They should have got a response immediately. Oh yeah, sorry, yeah, it did work. Let's try that again. Oh yeah, so they got responses even though like the server was down. No, they didn't. So contract's running. Yeah, there we go. So if we then spin that down and then restart client. Okay, for some reason it's not working. It worked before. So the other thing I wanted to demonstrate. Okay, I'm not sure what's going on. I'll have to debug that later. The other thing I wanted to demonstrate is like the distribution of work. So if we spin that down to 0 and then do like 100 battleships and then like spam them with messages. All of those messages will be then like equally distributed over the cluster. So here we're like firing like thousands of messages into the cluster. If we look in here and look at the logs for each one, we can kind of like see like the messages like evenly being distributed over all of your runners. All right, well, that was all for the demo. So what's next? The next part of this was looking at workflows. So using these building blocks, this like kind of like persistence we've added to messaging, we wanted to then do like durable workflows, which you can kind of like think of as durable effects. And we also want to make sure like the effect like cluster backend is optional, so you can then work. If you wanted to swap out like the workflow backend with something else, cluster would be optional. Another thing we want to look at for cluster is browser support. So you could have like a cluster in the browser. So if you're doing like a single page application, you could then distribute work using like web workers. Another thing we want to look at is runner parallelism. So Node.js is single threaded. So we need to look at a way to make sure like if your machine has 4 CPU cores, that each one of those cores is being used. And then we also want to look at adding like more resilience to the shard manager. So right now, you only have 1 shard manager, but then we might need to look at something like leader elections. So you could have like 3 shard managers. And if one of them goes down, another one is elected, and then adds like resilience to that. And also like an API gateway proxy. So for the outside world to talk to your cluster, you could go through like a gateway proxy and then have a similar API to the client we looked at earlier, but doesn't have to like connect to the cluster directly. So when can you use it? Now. I just need to merge a PR. But it's very, very alpha at the moment, and there will likely be bugs, as you probably just saw. So we're definitely looking for feedback, and please don't run your production workloads on it yet. But yeah, hopefully you got an idea what Cluster is about and what we've been working on for the past little while, and hopefully you guys use it and love it. Thank you.